the discriminant of a quadratic equation. Do not forget to subscribe, and if you have any question, feel free to ask or suggest anything. Now let's take another look at the quadratic formula used for solving equations in the form. This formula is called quadratic formula. The quadratic formula may be used to solve any quadratic equation. As you should remember, the coefficients a, b, and c from equation are substituted into the formula, and after some calculations you get the solution of the equation. The expression under the square root is known as the discriminant and is often represented by the delta symbol. Closer inspection of this formula indicates that much can be deduced from the discriminant because it can be positive, zero, or negative, and this determines how many solutions there are to the given quadratic equation. If delta is positive, then square root of delta is a positive real number, so the equation will have two different real roots. This is because taking the square root of a positive number will produce another positive real number. This implies that there will be one solution corresponding to the positive term and one solution corresponding to the negative term. If delta equals 0, then square root of delta is 0, so the equation will have two equal real roots. You can think of an equation with two equal roots as having only one solution or a repeated solution. This is because taking the square root of 0 gives 0. This implies that there will be only one solution because adding or subtracting 0 to the minus b term in the numerator will not alter the answer. If delta is negative, then square root of delta is not a real number. Therefore, the equation will have no real roots. This is because the square root of a negative number will not produce a real number. This implies that the formula cannot be utilized. Use the discriminant to determine the nature of the roots of each equation. Write the coefficients. Substitute the values and evaluate the delta. Since delta is negative, there are no real roots. Write the coefficients. Substitute the values and evaluate the delta. Since delta is positive, there are two different real roots. Write the coefficients, substitute the values, evaluate the delta. Since delta equals 0, there are two equal real roots. Find the value of k for which the equation has two different real roots. For the equation to have two different real roots, it must have delta positive. Substitute the values and solve the inequation. For two different real roots, k must be less than 3. Find the value of k for which the equation has one real solution. For the equation to have one real root, it must have delta equal 0. Substitute the values and solve the equation. Take the square root. For one real root, k must be plus or minus 1. Find the value of k for which the equation has no real solution. For the equation to have no real roots, it must have delta negative. Substitute the values and solve the inequation. For no real solution, k must be greater than 1 over 4.